Imagine walking into a meadow where every flower is black. It sounds beautiful, almost magical. But in real nature, that meadow is rare. Most flowers are white, yellow, pink, red, purple, or blue. So why do flowers almost never choose black? First, we need to correct the question. Black flowers do exist, or at least flowers that look almost black. Some are so dark they seem like little holes cut out of the garden. But if you shine light through a petal or look closely, many black flowers turn out to be deep purple, dark red, brown, or maroon. So the mystery is not, why can't flowers be black? The better mystery is, why is true black so rare? To solve that, shrink down into a petal. A petal is not colored like a painted wall. It is more like a tiny stained glass window. Inside, its cells are pigments, molecules that absorb some colors of light and let other colors return to your eyes. Here is the child-friendly version. Imagine sunlight as a box of crayons. A red flower hides most of the crayons except red. A yellow flower hides many colors, but sends yellow back. A purple flower sends back a mix that your eyes read as purple. The accurate version is this. Pigments absorb specific wavelengths of light. The color we see is the light that is reflected, transmitted, or scattered back. Now, black is a tougher job. A black petal has to absorb almost the whole crayon box. Red, orange, yellow, green, blue, violet. It cannot just specialize in one slice of light. It has to swallow nearly everything. That usually means packing the petal with dense pigments, often anthocyanins, or combining pigments and structures so very little visible light escapes. This is why many black-looking flowers are really extremely concentrated reds and purples. But chemistry is only half the story. A flower is not just decoration. It is a signpost. It is trying to guide a visitor, a bee, a butterfly, a bird, a moth, a beetle, or a fly. And those visitors do not see the world the way we do. Some insects see ultraviolet patterns that humans cannot see at all. Some pollinators care more about scent than color. Some visit at night, when pale flowers can stand out better than dark ones. So imagine a flower as a tiny shop sign. If your customers fly by in daylight, your sign needs contrast. Yellow against green leaves can pop. White can shine in dim light. Red can stand out to birds. Blue and purple can work well for many bees. But black. Against soil, bark, shadows, and dark green leaves, black may disappear. Not always, but often enough that it is not the easiest general advertisement. Now comes the next twist. Black can sometimes be useful. A dark petal can warm up faster in sunlight, like a black t-shirt on a hot day. In cold places, warmth can matter. A warmer flower may help its own reproductive parts, or make a tiny, warm resting spot for an insect. But that same heat can be a problem in hotter habitats. Delicate petals, pollen, and ovules can be damaged by too much heat, so black is not automatically better. It is a trade-off. And there is another special case. Some flowers do not advertise like a sweet candy shop. They advertise like a trap, or like rotting matter. Certain dark, dull, or foul-smelling flowers attract flies or beetles that normally investigate decay. In those cases, dark colors can fit the illusion. But that is a specialized strategy, not the main rule of flowering plants. For most flowers, the winning strategy is not be the darkest. It is be noticed by the right visitor at the right time without paying unnecessary costs. That is why the world is full of bright petals. A flower's color is a message, and black is a message with a very narrow audience. So why are flowers not black? Because black is difficult to make, sometimes harder to see, and often too specialized. Nature can make near black flowers. It just rarely makes black the best billboard. The garden is not missing black. It is full of signals, and most of them are written in brighter ink.